Tech in 5.
Dive into Python with a fun game, learn in just 5 minutes. Want to create a game with PyGame? Follow me. By the end of this video, you'll learn how to do it. Let's dive right in. First up, we invoke the init method from PyGame. Think of it as a starting bell. It gets all the necessary PyGame modules up and running. Following that, we set up our game's display screen. I'm using size constants for our game window, ensuring everything fits just right whenever the size needs to be changed. Lastly, we give our game window a title using the setCaption method. This will be the name displayed at the top of our game window. Now, let's turn our attention to the constants. In our game, I've set specific constants for elements like colors, screen dimensions, and block sizes. We also have constants for directions, which we'll delve into shortly. Why use constants, you ask? They serve as clear labels, making our code easier to read and understand. Alright, let's explore the heart of our game, the worm class. When our worm is created, the method initialization is called automatically. Here, the worm starts with a body, made up of 5 segments, represented as coordinates. The worm's initial direction is set to down, making it move downwards on the screen. The head method gives us the frontmost part of our worm. It's important because many game mechanics, like checking for collisions or eating beans, relies on the worm's head position. The move method is where the magic of motion happens. The worm calculates its next position based on its current head's position and direction. Notice how we add the new position at the beginning of the body list and remove the last segment? This gives the illusion of movement. Whenever our worm eats a bean, we want it to get longer. The grow method adds another segment to the worm's tail, symbolizing its growth. The direction methods control the worm's movement direction. They also contain safeguards. For instance, if our worm is moving to the right, it shouldn't be allowed to make an immediate left turn. That would make it collide with itself. With these methods, our worm can move, grow, and navigate through the challenges we set for it. Next in our journey, let's talk about the bean class, the food source of our worm. When a bean comes into existence, the initialize method is automatically invoked. Within it, we determine the bean's position randomly by using the random function. The x-coordinate of the bean can be anywhere, from 0, the far left, to width -1, the right side of the screen. Similarly, the y-coordinate can be anywhere from the top, 0, to height -1, just the screen's bottom. This way, each time a bean is created, it gets a surprise position on the screen, providing a fun challenge for the player to navigate the worm towards. Now, let's get our attention back to our main game. At the heart of our visual experience is how things are presented on screen. The draw block function does precisely that. It takes a position and color and uses PyGame's draw rectangle method to create a visual representation on the screen. Given the screen dimensions and our block size, this function calculates where exactly to place each segment of the worm and the bean. To visualize our worm, the draw worm function steps in. It loops through each segment in the worm's body and paints it using our draw block function. For our beans, draw bean gets the job done. It picks each bean's position and uses draw block to show it on screen. Every game tick, we need our worm to shift, glide, and twist. How? The worm's move method handles the motion. The worm's new head position is determined based on its current direction. By adding this new position at the front and removing the last segment, our worm appears to move seamlessly. However, movement isn't without danger. If our worm's head collides with its body or the screen boundaries, the game ends, adding a layer of challenge to our players. As our worm roams around, its goal is to consume beans. When the worm's head overlaps with the bean's position, we make the worm grow and then spawn a new bean at a random location. This adds an element of reward. The beauty of games is in player interaction. Here, we've embedded keyboard controls. By listening to the keydown event, we detect when a player presses an arrow key. Depending on which arrow key gets pressed, we invoke the direction changing method on our worm, ensuring it turns based on the player's commands. Now, let's enjoy our game.
Stay tuned for more videos on Tech in 5.